For more than half a century, Waukesha Cherry-Burrell has been a leader in the design, manufacture, and application of external circumferential piston-style positive displacement pumps. The Universal 2 Series PD pump is an extension of this tradition. It combines three-way mounting versatility introduced by the Universal with new features that extend pump life and improve sanitary performance. The Universal 2 series of pumps is available in 10 sizes with capacities that range up to 312 gallons per minute. Standard features include the Waukesha Cherry-Burrell non-galling number 88 alloy rotors, large diameter heavy-duty shafts, and the versatile Universal three-way mounting. The Universal 2 provides extremely high volumetric efficiencies and up to 450 psi pressure capability depending upon model. This video reviews the proper care and handling procedures of the fluid head and gear case of a typical Universal 2 series pump. The fluid head section will be of interest to both your operations and maintenance sections. The gear case will interest only the maintenance section. By following these procedures, you will help assure that your Universal 2 pumps provide long, trouble-free service. Before beginning to disassemble the pump, check that you have all required replacement O-rings and that the O-ring material is appropriate for the product to be pumped. Maintaining the popular Universal 2 paint pump, for example, which is especially designed to handle auto and truck solvent and water-based paint products, is virtually no different than the standard Universal 2, except that O-rings are Cal-Res or PTFE encapsulated and sealants are silicone-free. You'll see these installed in the course of the video. In addition to having proper O-rings on hand, you may need replacement grease seals, oil seals, new bearings, and lubricants. If the pump is worn or damaged and you are facing pump overhaul, you may need new rotors, shafts, and shims. Because Universal 2 series pumps are precision-made and have extremely close running tolerances, take care when cleaning and handling the fluid head, which includes the cover, body, rotors, and seals. Catching wear early is important to reducing your maintenance costs. Periodic checking of lubrication, noise, vibration, and bearing temperatures are recommended, as well as a simple look-feel inspection of your pump. Waukesha Cherry-Burrell recommends changing the oil at least every 500 operating hours. The bearings must be greased at least every 250 operating hours. If the pump is installed where moisture and condensation are heavy, lubrication should be made more frequently. Excess grease will accumulate in the bearing housing and can be removed through the lower cleanout hole fitted with the plastic threaded plug. Before working on your Universal 2, disconnect and lock out all power. In addition, drain product from the pump prior to disconnecting piping. If isolation valves are in use, close them and disconnect the inlet and discharge lines. At all times, keep your fingers out of the pump ports. Remove the cover nuts. If your Universal 2 is equipped with optional three-wing cover nuts, use a soft hammer to loosen them. Metal hammers will damage pump parts. The wing nuts are also fitted for an Allen wrench. Next, remove the cover. If it's stuck, loosen it with a soft hammer, but don't use screwdrivers or other hard objects. When the cover is loose, remove it from the body studs. Be sure you have adequate support for the cover, especially on the larger units. Place the cover on a rubber mat or inside up on the floor or bench. This will help avoid nicks and scratches on the sealing surface. Use a rotor nut wrench or socket to locate the rotors perpendicular to each other. The rotor timing should now be checked. Clearances on both sides, wingtip to wingtip, must visually be equal. Remove the rotor retaining nut of the horizontally oriented rotor. It's a good practice to avoid using a torque wrench for this. You might torque it out of calibration. Use a regular wrench or breaker bar. Lock the rotors in place with a nylon or hardwood dowel so you won't damage these parts. Each rotor nut has a Belleville washer and 2 O-rings. Remove this horizontally oriented rotor. Remove the remaining rotor retaining nut with the wrench, again locking the rotor in place with the dowel. Remove the rotor. The rotors are sealed off so they shouldn't hang up, but if they do, here are 3 handy ways to unstick them. Try prying with wood or plastic dowels. If this is unsuccessful, back out the body retaining cap screws and tap the body forward with a soft hammer. Then just tap the body back and remove the rotors by hand, or by prying with wood or plastic dowels. Although it's rarely needed, a gear puller will help you remove rotors that resist other methods. The puller should contact the rotor in these 2 places. Use a mill file to remove any raised areas made by the puller. After removal, place the rotors on a rubber mat or place the rotors hub down to avoid damage to the rotor wings and front rotor hub outside diameter. Remove and discard the rotor hub O-ring and rotor nut O-rings. If the body retaining cap screws have not been removed yet, remove them now. Remove the pump body by pulling it straight off the body studs. Use a soft hammer and tap on the ports if the body is stuck. Use care to take off the body straight out so you won't damage the seals. Again, place the body on a rubber mat with the mechanical seals facing up. Be careful with mechanical seals and avoid dropping them. Check the rotor wings for indications of metal-to-metal contact. If this condition exists, they may need to be buffed or replaced. Generally, this contact is caused by a twisted shaft, by loose, worn, or mistimed gears, or by loose rotor nuts. Also, check for stress cracks on the rotor wings, which can be caused by excessive discharge pressures. Inspect the keys and keyways of the rotors and shafts for wear. Worn keys should be replaced. Rotors and shafts with worn keyways should also be replaced. This wear can be avoided if rotor nuts are torqued properly. Check the rotor end that locks against the shaft shoulder for wear, as well as the shaft shoulder itself. If this area is worn, a common cause may be extended running with a loose rotor retaining nut or repeatedly slamming the rotor in place on reassembly. If worn, the rotor should be replaced and the shaft should be re-shimmed to maintain the proper back face clearance. Remove the cleanout plug and inspect for excessive or contaminated grease. Bearing condition should be checked whenever the fluid end of the pump is disassembled. If you can detect movement of either shaft at the interface of the shaft and the grease seal, the bearings are failing and should be replaced. You can detect movement by hand loading the rotor end of the shaft to approximately 30 pounds of force. Bearings fail from lack of lubricant, high overload, or water or product contamination. You may have to reconsider your lubrication schedule or look for a means to reduce the hydraulic loads. Excessively leaking seals can lead to the bearings being contaminated by product. Bearings also may fail from over-greasing if excessive grease is not removed at the cleanout holes. If you can feel any free movement when you rotate either shaft without transmitting motion to the other shaft, it's an indication of excessive gear backlash. As the wear on the gears is at 180 degrees, redo the backlash check 2 times at 60-degree intervals. Generally, the cause for excessive backlash is loose or worn gears. Also, check for any axial movement of the shafts, looseness forward and backward. Inspect the mating surfaces on the fluid end and the gear case for paint, rust, raised nicks, and other potential interference with a proper alignment. Clean or remove with a mill file if necessary. Any interference will affect the back face rotor clearances. Similarly, you should clean and inspect all fluid head parts. Mechanical seals are standard with the Universal 2 series pumps. The single mechanical seal consists of 5 components: inner seal O-ring, shaft O-ring, seal seat, inner seal, and wave spring. Handle all seal components carefully. Remove the seals from the body, clean, and inspect them. Do not reuse a seal if the seal face is scratched, chipped, or cracked. Remove the inner seal O-ring and discard. If needed, use the convenient O-ring removal tool that came with your pump. Check with your local distributor about seal repair programs available on hard face seals. Remove the seal seats and the shaft O-rings. Use even pressure on both sides so that you won't crack the seats. The shaft O-ring should be replaced and the seats cleaned and inspected thoroughly. Do not reuse the seal seats if they're cracked, chipped, scratched, or grooved. In a typical repair, such as this one, when the faces are not damaged, they are not replaced. Depending on which seal arrangement your pump has, some color transfer between seal faces is normal. Before installing the new shaft O-rings, first turn the shafts and feel for burrs on the shaft shoulder that might damage the O-rings. Lubricate the new shaft O-rings and install them, taking care not to cut them while passing over the shaft shoulder. Check for dirt and debris on the seal faces. Install the seal seats, being sure to line up the drive flats on the rear faces with the drive flats on the shafts. Lubricate the inner seal O-rings and install them on each seal. Assemble the wave spring onto each seal and install them into the pump body, aligning 3 of the notches in the inner seal with the 3 drive pins in the body. The double mechanical seal consists of the single mechanical seal components with 3 additional components, an O-ring, an outer seal, and wave spring. For each seal, apply lubricant to the new O-ring for the outer seal and install it on the seal. Insert the wave spring and then seal assembly into the body, engaging 3 of the notches with the 3 pins. It's very important that all seal faces remain free of any dirt or debris. Then, lubricate the seal faces. To attach the fluid head body to the gear case of the pump, locate and identify the 2 dowels on the inside of the body and match them up with the appropriate dowel holes on the gear case. The dowels are different in size, so you won't fasten the body upside down by mistake. Carefully place the body over the shafts and studs, being careful not to nick seal components or knock them out of place. Press the body against the housing, engaging the dowels. You don't have to force the body snug by hand and risk seal damage. Simply use the 2 body retaining cap screws and secure the body to the gear case. Install new rotor hub O-rings onto the grooves in the rotors. Lubricate all O-rings with a lubrication compound that is compatible with O-ring material and process fluids. Apply a food-grade anti-seize compound to the shafts and body studs. Lubricate and install new rotor nut O-rings onto each rotor nut. Lubricating the new O-rings makes sure they won't pucker when the nuts are tightened. Install Belleville washers in each rotor nut with the cone of the washer pointing towards the nut. Place retainer O-ring onto rotor nuts to retain washers. When you shake the rotor nut, you should hear the washer rattle. The proper orientation of the washer is critical to maintaining the torque value of the retaining nut. Assemble a rotor onto a shaft and align the shaft key and rotor keyway. Install a rotor nut assembly onto the shaft, clockwise. Use a nylon or hardwood dowel to lock the rotor in place so you can torque the nut. Always use a torque wrench. Rotor nuts that are not tightened to the proper torque could loosen during operation and severely damage the pump. Check the operation, maintenance, and parts list manual for proper torque values. They're on Table 2. Using a rotor nut on this shaft and using the wrench, rotate the shaft until the rotor wings are in a vertical position. Install the second rotor and key. Install the other rotor nut assembly onto the shaft. Block the rotor with a dowel and torque it to spec. The rotor wings must be below the body face and can be felt with the fingers or thumb. You can also use a dial indicator or a straight edge and shims to compare front face clearances with table values. Install a new O-ring in the cover groove. It usually helps to stretch the O-ring if it doesn't fit freely into the groove. On the other hand, with PTFE encapsulated O-rings used in Calres fitted pumps, such as the Universal 2 paint pump, you have to take care not to overstretch them. When you remove a used PTFE encapsulated O-ring, take care not to use the standard O-ring removing tool. Just use air pressure to dislodge it. Replace it with a new PTFE encapsulated O-ring if necessary. Mount the cover on the studs and push it against the body, making sure the O-ring remains in the groove. As on the body, check the dowel pin hole size on the cover and match it with the appropriate dowel pin on the body. That's right, you can install a cover upside down by mistake too. Install the cover nuts on the studs and tighten with your wrench. Optional wing nuts can be tapped with a soft hammer. You can also use an Allen wrench to tighten the wing nuts. Waukesha Cherry-Burrell offers versatile options with the Universal 2 fluid head assembly. These include vented covers for pressure relief and jacketed covers to maintain product temperatures. CIP options including flat body profile for free draining capability and specially drilled CIP rotors and body. Flush taps for double mechanical seals and stainless steel gear cases. The second portion of this video presentation will show the proper disassembly and reassembly procedures for the gear case components. Remove the oil drain plug, drain oil, and discard the oil. Remove cap screws from the gear case cover, then remove the cover. If the cover sticks, use a soft hammer to loosen it. Scrape the silicone sealant from the gear case and gear case cover. Remove the oil seal from the gear case cover with an arbor press or an appropriately sized tube and discard. Straighten the locking tabs on the lock washers. Prevent the shafts from turning by wedging a dowel or hardwood block in the rotors. To remove gear lock nuts, use the custom gear lock nut tool shown here, which is available through your distributor. You can also use a spanner wrench or drift. Gears will be removed later. Remove the front bearing retainer cap screws and pull off the retainer. Scrape the silicone sealant from the retainer and gear case. Place the housing in a hydraulic press with the fluid end down. See Table 4 in the maintenance manual for tons required. Protect the shaft ends with a wood or plastic block and press the shafts out of the gear case. Remove the gear spacer and gear keys. Now remove the timing gears. Then press out and discard the grease seals from the bearing retainers. If the shafts do not need to be replaced, label the shim stock according to the shaft it came from. Use drive shaft or short shaft on your label. This will eliminate recalculation of shim requirement. Press out and discard both of the rear oil seals in the gear case. Use a hydraulic press and V-blocks to remove the front and rear bearings and bearing spacers from the shafts. See Table 4 in the maintenance manual for tonnage required. Protect both ends of the shafts from damage. The procedure for assembling the front bearings is identical for both shafts. Begin by placing the shaft upright in a hydraulic press with the fluid end down. Coat the front bearing area of the shaft with microplate number 555 grease. Unwrap the front bearing assemblies. Take care not to interchange the parts of one bearing assembly with another. These parts are precisely matched in manufacture and must be installed as matched assemblies. Lift the cone and roller assembly out of the bearing stack and place it on the shaft with the radius down. In all cases, when pressing bearings onto the shaft, press only on the inner diameter or bearing race. Make sure you have the proper size driving tube. You may need several sizes for the different bearings. Press the cone and roller assembly onto the shaft until it is seated against the shaft shoulder. Again, refer to Table 4 in the manual for tons required. Place the front inner bearing spacer over the shaft onto the bearing cone. Place the lower bearing cup over the lower cone and roller assembly. Keep the cup oriented with the proper roller assembly. Place outer bearing spacer on top of that lower cup. Then place upper cup on top of the outer spacer. Coat the inside diameter of the remaining bearing cone and roller assembly with microplate number 555 grease and slip it over the shaft with the roller radius up. Press onto the shaft and into the cup to complete assembly of the front bearing. Make sure all components are aligned before you press, and press only on the inner cone assembly. We've just assembled a 6-piece front bearing assembly. Some pump models utilize a 4-piece front bearing assembly, such as this. Install the bearing spacer. Unwrap the rear bearing assembly. Some larger pump models have a multi-component tapered roller bearing assembly, similar to the front bearing assembly shown earlier. For single-piece bearings, the shielded side fits against the bearing spacer. Again, always press on the inner diameter or bearing race. Check Table 4 for the proper hydraulic press tonnage. Install gear spacers and gear keys. Carefully tap keys in. Leave a slight angle on the key, as shown, to aid in assembling the gear onto the shaft. The next step involves shimming, which, when done properly, assures the correct front face and back face clearances for trouble-free operation. Of course, if the shafts did not need to be replaced, the shims don't either. Use the shaft shims that you have identified specifically with each shaft. Just remember, same shafts, same shims. If you're installing replacement shafts, you can save yourself time and effort by delaying the assembly of bearing retainers, gears, and lock nuts until you have verified correct shimming. You may need to remove shafts once to adjust shimming before you achieve the proper clearances. Those of you who are comfortable with precise measuring tools and techniques to thousandths of an inch should follow the steps outlined in your maintenance manual under shims, all models. For a more hands-on method, refer to the table in your manual that provides suggested shims, inches, and note the replacement shaft shim requirements for your pump model. Use standard shim packs to equal the required shim thickness. With both existing and new shim packs, arrange the shims so that the thicker ones are on the outside and the thinner ones on the inside. Place them against the shoulder in the front bearing bore. With the proper shims in place, install the shaft assemblies in the bearing housing with the fluid end up and the drive shaft in proper location to give top or bottom drive as required. Press the shaft into the housing until it's seated against the shim pack. The sleeve shown is a custom tool that presses against the outer race. You can obtain this tool from your Waukesha Cherry-Burrell distributor. Remember, always press on the outer race only when pressing a shaft and bearing assembly into the gear case. Temporarily secure the shaft assemblies in the gear case with the bearing retainers. Add no silicone sealant at this time because we're just checking clearances. The retainer must seat firmly against the bearing and leave 10 thousandths to 50 thousandths clearance with the gear case. If necessary, use shims between the bearing and retainer. Now, temporarily assemble your pump, minus gears and lock nuts. You can do this with the fluid end up or by securing the body tightly against the gear case with just the body retaining screws. Then, write down the rotor clearances for A, the back face, which can be measured from the front or the port. B, the rotor to body, and C, the front face. Check these clearances against those listed for your pump model in Table 1 in your manual, Standard Rotor Clearances. If your pump application involves high temperatures or products that tend to coat, such as chocolate, you may have special clearance rotors. Contact the factory for proper B and C clearances. You may not achieve the listed clearances the first time. Disassemble and adjust shim thickness to meet these back face clearances. Be sure your back face clearances, or dimension A, for both rotors are identical. This prevents rotor crossover contact. After you remove the fluid end from the gear case, remove the bearing retainers. Grease the front and rear bearings through the grease fittings until grease is visible around the ball assemblies. Rotating the shafts while you grease helps disperse the grease properly. Hand packing grease into the bearings also is acceptable. Install the grease seals into the bearing retainers with the lip facing out. Coat seal lips with microplate number 555. If your pump is a Model 30, you'll find the grease seal has to be pressed slightly farther. Coat the bearing retainer flanges with silicone sealant. For the Universal 2 paint pump and other silicone-free pumps, use Gore-Tex sealant. Then install the bearing retainers. Coat the ID and OD of the oil seals with microplate grease number 555. Press in the oil seals with spring facing out. Before installing the timing gears, identify the gear with the single punch mark. It will be the drive gear. Now check the one with the 2 punch marks. When installed, the 2 punch marks will straddle the single mark. You'll find it helps to put the rotors at right angles before aligning the timing marks. Then, slide the gear with the single punch mark onto the drive shaft and the gear with 2 punch marks onto the short shaft, again with the 2 punch marks straddling the single mark of the drive gear. The gears may need to be tapped into position. Slip on the lock washers and apply microplate grease to the threaded area on the shafts and to the face of the lock nuts. When you're removing or torquing the lock nuts, you need to prevent the shaft from rotating, and here are 3 useful ways of doing it. With a wood or nylon block wedged between the gears, with a rag in the gears, or with a dowel or hardwood block in the rotors. You can tighten the lock nuts with a spanner, wrench, or drift, but we recommend you use a torque wrench and socket spanner as shown here. Refer to Table 2 for tightening torque. Bend the locking tabs to secure the lock nuts. This handy socket spanner is available from your Waukesha Cherry-Burrell distributor. Press a new grease seal into the gear case cover with the spring side facing in. Place silicone sealant on the back of the gear case. Be careful to stay to the inside of the bolt holes. For the Universal 2 paint pump and other silicone-free pumps, apply Gore-Tex on the back of the gear case, again staying inside the bolt holes. Lubricate the gear cover's grease seal with microplate number 555 to keep it from running dry against the drive shaft. Then mount the cover assembly over the shaft extension onto the gear case. Be careful to protect the seal from the keyway with tape. Before securing with cap screws, make sure the shaft is centered in the lip seal. Fill the gear cavity with microplate number 140 oil to the proper level. Refer to the oil capacity chart in the operation section of the manual. This is important because over-oiling is a common error. If your pump is side-mounted, it will require more oil in the gear cavity than horizontally ported pumps. Install the fluid into the gear case assembly, and take care not to damage seals as the body is drawn over the shafts. Install rotors and rotor nut assemblies and install the cover. You have now become a part of the Waukesha Cherry-Burrell pumps tradition. When you follow the procedures we've just covered, your Universal 2 Series pumps will provide long, trouble-free service. If at any time you are unable to continue your in-house pump repair activities or would benefit from additional repair resources during peak activities, you can turn to the people at your nearest Waukesha Cherry-Burrell Certified Pump Repair Center. They're able to turn to your repair needs quickly with factory-trained technicians who regularly attend ongoing maintenance seminars. Using only genuine, original equipment parts, they will fully inspect and repair your Universal PD pumps so they can continue adding value to your process.